Hello students, and welcome to our lesson. So today we're going to look at the factors affecting the rate of a reaction, and one of the factors that affects the rate of a reaction is temperature. So how does temperature affect the rate of a reaction? So from your Form 1 work where you looked at the kinetic theory, you said you learned that when you increase the temperature then you increase the kinetic energy of the particles, and so the particles will tend to vibrate more vigorously or faster. The same case applies here. So when we increase the temperature, we increase the kinetic energy of our reactant particles, and that leads to an increase in the effective collision frequency, because the reactant particles must collide with each other to form the products. So an increase in temperature therefore will lead to the increase in the rate of a reaction. However, we need to note this, and in the next lessons we're going to note that it's not in all the cases where an increase in temperature will favor a certain reaction. We're going to look into that in our next part. A good example of a case where we can a simple experiment or equation that can be used to prove that we can react sodium thiosulfate with hydrochloric acid, and once we react the two, we should be able to form sodium chloride, sulfur 4 oxide, sulfur, and water. So sulfur here is normally a yellow PPT. So remember, sodium thiosulfate is a colorless solution. This one is colorless. Same case to our hydrochloric acid, it's colorless. This one is also colorless. Same to our gas here, and the same to our water. So we can react these two reactants varying the temperature and see how fast the reaction will take to form a completely yellow solution due to the formation of the yellow sulfur. And once you do such an experiment, then you should be able to discover that if you drew a graph of time taken to form yellow PPT against temperature, of course in degrees Celsius, you should be able to discover that you should obtain a curve. This curve shows that the higher the temperature, so remember on the x-axis, as you move on the x-axis, temperature is increasing. So the higher the temperature, the less time you are taking to form the yellow precipitate. And the opposite is also true. The lower the temperature, like in this case, the temperatures here are very low, then you have to take longer time. You have to take a longer time for you to form the yellow precipitate. So next we're going to look at concentration. So our next factor which we're going to look at is concentration. And of course we know what concentration is. Concentration is the same as molarity, and molarity is the number of moles per liter. So how does affecting the concentration of the reactant going to affect the rate of the reaction? So increasing the concentration of the reactants increases the number of the reactant particles, and hence results to an increase in it increases the chances of having an effective collision. So when increased concentration, in short, you are adding more particles, and so the chances of having an effective collision increases. So increase in concentration will always result to the increase in the reaction rate. So there are very many experiments that you can do on this, especially in your paper 3. And of course, you need to know how to draw those graphs